Right. Thanks, Adelaide, for the introduction, and welcome back, everyone. Just like Adelaide had said, my name is Mao Amis. I run a think tank called the African Center for Green Economy, based here in South Africa, but working across the region. So it's a pleasure to moderate this session of the conference, and I really, having sat through the first session and very intense moment, you will notice that the meeting started by going deep, really prioritizing the issues around just transition, looking at the transparency, and really how do we make this transition much more inclusive. And then after that session, we kind of zoomed out a little bit to look at the coal transitions and how coal transition could enable broader energy systems. And so this third session, we are going to go back, basically delve much deeper as well to look at what happens in coal mine closures and the use of post-mining areas. And the objective of this session really is to explore strategic planning and planning mechanisms to manage mine closures to ensure that it's just for communities and to be able to mitigate any socioeconomic and environmental impacts that might arise out of closing these mine systems. But the key issue really here, having heard from the different countries, is that there are lessons that can be shared, particularly from the EGAT project. And so this session will introduce some really innovative approaches that are utilizing some really excellent post-mine techniques to ensure that these post-mine areas are managed well and ultimately benefit communities to that effect. And so for this session, we've also lined up an excellent lineup of participants, and I will introduce them individually later. But for this session, I would like to first of all welcome Nonhlanhla Radebe, who is a water specialist from WWF, to talk to us about mineland water rehabilitation in South Africa. It's a pleasure to have you around. I'm an ex-WWF, so welcome to the family again. Thank you.
Good morning, colleagues. First of all, I would like to thank GIZ for extending an invitation to WWF to present and giving us an opportunity to learn from colleagues around the world who are also in the process of transitioning to a low-carbon economy. Today, I'll be giving a brief presentation on mineland and water rehabilitation in South Africa. I'll also share, in addition to the slides, the notes I have prepared for this session, so colleagues will be able to follow some of the things that are not in the slides, but I'll highlight in the presentation. So first of all, I'll just be giving a brief overview of South Africa's coal mining landscape, the environmental challenges of mining, the legal and policy frameworks for water and soil rehabilitation, and also providing an introduction to the Just SA project outputs and activities that WWF is implementing for the EGAT project. So just to look into just some statistics, the South African Department of Mineral Resources and the US Geological Survey indicate that South Africa possesses ore reserves amounting to a value of more than $2.5 trillion, with 16 commodities ranked in the top 10 internationally. Water pollution examples such as acid mine drainage, heavy metal contamination pollution from processing chemicals and erosion, as well as sedimentation, which has a negative impact on the community surrounding the mines, and biodiversity are some of the challenges that we grapple with when it comes to coal, as well as land contamination from coal mining. So land pollution, such as the generation of mining waste, tailings, waste rock dumps, and activities such as strip mining where the top layers of the soil and vegetation are removed, and other impacts such as deforestation, erosion, contamination, and the alteration of soil profiles, as well as the contamination of local streams and wetlands, are some of the impacts, negative impacts to the environment that mining brings. But of course, over and above the environmental impacts, you also see there are quite a number of socio-economic impacts as well, where some communities are being displaced, have been displaced rather, and some feel that they have not benefited economically from mining, but bear the environmental consequences thereof. So in the next slide, there are different sources that cite that the number of coal mines globally and in South Africa. Some say there are about 3,025 coal mines in operation globally, and 108 of those are in South Africa. South Africa gets more than 80% of its energy from coal. And at present, with Eskom, our state-owned energy provider, being in operation since 1923, the bulk of our energy comes from Eskom. In Mpumalanga, for instance, the Wolverkrans, Middelburg complex, and the Kriel mine have abundant coal reserves and provide much of this. There is an intersection, however, between coal reserves and some of the water source areas in the country. So you see that there is an intersection between strategic catchments, water catchments that produce disproportionately higher volumes of water per unit area than other areas, and some of the coal mines. So the risk of contamination is really quite high. The impacts on soil and water are varied, and acid mine drainage being one of the major impacts of water contamination and a very big area of concern. So there are quite a considerable number of mines in South Africa, but the coal fields in Mpumalanga are concentrated in 5 coal fields. So that is here. So you see that there are 5 main coal fields. So there's Ermelo, Vryheid, there's the Highveld, the Klip River, and Utrecht coal fields. So out of these, you see that in this picture right here, there's a huge environmental impact with this stream. You see some acid mine drainage and some precipitation of metals within the banks of this stream. But if you zoom in closer into this cross-section of this crocodile tail of a crocodile that lives in a contaminated area, you find that there's accumulation of metals even within the tissues of the animals that live in these contaminated streams. What more the impact on human beings that are living within these streams. So there are quite a number of legal frameworks and water rehabilitation that the government has set up in South Africa, and the legislation has evolved in recent years, but unfortunately the implementation of this legislation has been an area of concern because assigning liability still remains problematic. So there are 9 key pieces of legislation, or rather acts that have an impact on the issue of rehabilitating water and land. And first and foremost, it's important to note that just Section 24 of the South African Constitution also deals with the issue of leaving the environment in a state that does not impact on the lives of people. And then over and above that, you also have Section 41 of the Mineral and Petroleum Resources Development Act, which outlines 4 methods for financial rehabilitation provision. But the focus is mostly on surface rehabilitation. And the National Water Act leaves some gaps in retrospective liability, where it's not always clear how the owners that caused the harm to the environment are held liable. And of course, you also see that within the within all of these discussions about the legal frameworks for soil and water rehabilitation, WWF, as well as other partners, has been actively contributing to the mine water closure strategy and has published a briefing paper in 2019-2020. The Minerals Council has also published a manual for the authorization of pit lakes as a closure option and the Water Reuse and Reclamation publication. The Water Research Council has also issued several guidelines on reusing mine-affected water, and MinTech, alongside the universities of Pretoria, the universities of Cape Town, have also made significant progress in water treatment and land rehabilitation research. So this brings me to just frame the project that we are currently implementing as WWF for the EGAT project. The project is set to run from 2022 to 2027, and the Just SA project seeks to contribute to developing pathways to achieve a low carbon, climate resilient and more equitable economy. The implementation of the consortium partners is led by GIZ South Africa, with partners TIPS, NBI, YES, and WWF South Africa, and is funded by the German government International Climate Initiative. And the political partner for this project is the Department of Forestry, Fisheries and the Environment. So the South African Cabinet approved the Just Energy Transition Framework in November 2023, which sets out interventions and investments needed for South Africa to meet its decarbonization commitments. There's also a strong social aspect where there needs to be involvement of the communities around these coal mines as well as coal-powered stations in order for it to be a truly just transition. The people's voices need to be heard as well. So if you look at some of the project outputs in the Just SA project, we are focusing on getting technical solutions that are feasible, that are not only feasible, but also consulting with interested and affected parties that are impacted by the just transition within Mpumalanga. This function is mostly through the stakeholder advisory group, which includes trade unions, academia, the private sector, and the different provincial government departments that are dealing with water and land rehabilitation within the Mpumalanga province, such as the Department of Water and Sanitation, the Department of Agriculture, Land and Environmental Affairs. So the options for acid mine drainage, with input from the technical advisory group, as well as the options for treating acid mine drainage, as well as land contamination. We are getting feedback from the technical advisory group, as well as looking at developing an economic analysis using full cost accounting for land rehabilitation and water treatment and restoration of ecological infrastructure. Setting up proto-business cases in land rehabilitation and water treatment, and viable nature-based solutions will be prioritized. And the recommendation for a water treatment facility, which enjoys the support of implementing actors and the mechanisms of delivering output 4 of the technical advisory group. So the stakeholder advisory group, bilateral workshops, and local communities are very much a part of the project, and establishing a mine water treatment working group. So we want to be in a position where we help to develop and establish cooperation and knowledge exchange with universities around the world that are also taking part in the transition process. And we also want to involve relevant stakeholders and model different approaches to mine closure and conduct gap analysis on hindrances in financial provision for mine closure. and mine closure and rehabilitation, including business and the creation of a business and social model for mine rehabilitation and water treatment, and providing technical advisory support to relevant authorities and, if applicable, mines to monitor water quality. So just a practical, some of the work that has been done, there has been some work already done, like for instance with phytoremediation, where we are looking at various viable options regarding phytoremediation, and also looking at work that has been done by, for instance, Professor Broadhurst from UCT. And there's also a paper that was being presented, Driving Post-Mining Industrial Development, which is this one, which is this paper. And in this paper, they also highlighted just driving some post-mining industrial development through using fibrous multi-product value chains, such as bamboo as well, which can be used to bioremediate contaminated soil. South Africa has a naturalized bamboo species, namely bamboo balboa, which is also known as the giant bamboo, which was introduced to South Africa by the Dutch East India Company, and its species grows well in KwaZulu-Natal, Mpumalanga, Eastern Cape, as well as the Western Cape provinces. Other plants that can be considered for phytoremediation include kenaf, hemp, and other fibrous plants, which can be industrialized for economic beneficiation. And then I just want to end off by giving just presenting this pilot project, which is a very good example of a public-private partnership case study of a project initiated by the Department of Water and Sanitation and the Water Research Commission. This was spurred on by the devastating impacts of drought and the grappling several parts drought that has grappled several parts of the country. And of course, this is one of the impacts of climate change and forms part of the South African government's national long-term approach. So Anglo Coal has proven that in this project, Anglo Coal played quite a pivotal role, because they are also a mining company, but they are also part of this project because they played quite a pivotal role in providing this Mafube colliery where this project was piloted. And so here they basically used treated mine water to irrigate crops. And so the Anglo-American Mafube colliery dedicated resources toward the establishment of the infrastructure, including the drilling of monitoring wells that are usually used to monitor the water quality in a longitudinal study. This is an example of what opportunities could be possible, but not only limited to this, of course. We're looking at other different possibilities, which could be possible for rehabilitated mine land and the use of treated mine water for agricultural purposes. Thank you so much. I think my time is up, and these are some of the references.
Thanks, Nonhlanhla, for an excellent summary of what is happening. And I can just summarize your presentation in 3 key points. For those who don't know, Mpumalanga, which is where a lot of the coal plants are located, is also one of the most important water catchments for South Africa. So some of the most important water towers of this country are located there. So the issue around trade-offs around energy and water is really, really important, and has been illustrated through the acid mine drainage issues that has been arisen. And the second issue is around, South Africa has a plethora of policies, actually. We don't lack policies, just really how do we implement faster in an effective way. And thirdly, is this approach of multi-stakeholder engagement, because we deal with the wicked problems. You have to have everyone around the table, private sector, civil society, government, and so on. So really an excellent example of how we can hold hands together to drive this transition to a much more inclusive economy. So our second presentation, ladies and gentlemen, is going to be online. So just shift gears a little bit. And we're having Ryan Driskell Tate, who is director for the Global Energy Monitor. He's going to be talking to us today about methane emissions from coal mining. Ryan, can you hear me?
I can. Can you hear me?
Yes, thank you so much. The floor is
Great.
yours.
Excellent. Well, hello, everyone. Look, thank you for having me. It's a pleasure to join you virtually. And today I want to speak about a critical issue of climate change and just transitions, which is coal mine methane emissions, or CMM. So on our first slide, just as way of introduction, Global Energy Monitor publishes open source data sets on energy infrastructures with more than 24 projects currently available, including our global methane emitters tracker, which is actually featured here in our next slide. The project provides asset level estimates for coal sites around the world and attributions of observed methane emissions from satellites and aerial flights. So we cover 146 countries and have accounted for 92 million tons of methane emissions at the asset level and have attributed over 1,800 satellite observed methane emission leaks to energy infrastructure. Next slide. So this is that tracker there. And then we can go to the next slide. So methane gas is trapped in underground seams formed during early processes of coalification. It is released during and after mining activities. Methane is one of the most potent greenhouse gases with a higher warming potential than carbon dioxide. We see emissions both at underground and surface mines. While mitigation of methane is possible, it's not currently the industry standard practice. So on the next slide, if you've ever wondered what is the big deal about coal mine methane, let me explain. Coal mine methane is responsible for about 1/3 of all the fossil fuel emissions, methane emissions globally. And according to the International Energy Agency, reducing those emissions by 75% by 2030 is a key requirement for the world to remain on path aligned with a 1.5 degree climate target. But emissions from coal mines aren't straightforward. They depend on various factors, such as the gas content of the coal seam, the depth of the operation, the amount of coal produced, and whether any mitigation measures are currently in place, like gas drainage or ventilation air methane. The truth is emissions are often higher in regions where coal seams are particularly gassy and where mitigation practices are lacking. On the next slide, we can see that one of the biggest obstacles we face is that we don't even know the full extent of the problem. Shockingly, 97% of coal mine methane emissions aren't directly measured. Many countries rely on generalized emissions factors that apply to the entire region rather than measuring emissions directly at individual mines. As a result, we have a wide spectrum and currently available emissions estimates, which you can see here. On the next slide, we can see that to make matters worse, many countries don't report the emissions at all. Independent studies have shown that there's 22 countries where coal mine methane emissions could be double what is currently reported. This underreporting is largely due to a lack of monitoring infrastructure and the fact that until recently, detailed methane reporting wasn't even a requirement under frameworks like the UNFCCC. And this is just an example of where sometimes you get different reporting, different estimates coming from different scenarios, independent assessments and government assessments. So how do we solve this? First, we need to improve the way we measure and report emissions. Right now, we rely on a combination of direct measurements, satellite observations, aerial flights, and estimation. Direct measurements involved installing sensors at the mine to capture real-time data on methane release. Satellite data, such as the European Space Agency satellites, allow us to detect large-scale emissions from space, while aerial flights equipped with methane detectors can zoom in on specific locations and provide more specialized readings. Together, these approaches offer a more complete picture of emissions, but on-the-ground measurements are still essential to accurately quantify the problem. But again, as I mentioned, they're not yet industry standard. So in this slide, there are several ways we can mitigate methane emissions from coal mines, and some promising technologies already in place around the world. The most simple is either not mining in the first place or improving the housekeeping at current operations that all coal mines currently manage methane for safety reasons, but improving those processes, such as borehole design, could actually reduce emissions. Another key mitigation technique is pre-drainage, which removes methane before the coal is extracted. This technique has successfully been implemented, for example, in the United States, at the Harrison County coal mine in West Virginia, in Australia, at the Ironbark coal mine, where methane is drained from coal seams beforehand. Another example is the ventilation air methane oxidization technology. The ventilation of air methane can be vented or oxidized, and the Xi coal mine in China has the potential to operate one of the largest VAM oxidization systems in the world, which would capture and oxidize methane from the shaft and generate heat and power. There's also post-mining drainage, which captures methane after the coal has been mined. For instance, in Poland, operators can capture methane and use it to generate electricity, which reduces methane emissions while supplying power to the grid. In addition to these systems, coal mine methane flaring is an effective way to reduce methane's potency. Flaring combusts the methane, converting it to carbon dioxide, which is significantly lower global warming potential. Anglo American had flaring operations ongoing at their New Denmark colliery in South Africa, which was one of the country's deepest mines. The utilization of coal mine methane is another option. Currently, there are over 200 coal mine methane utilization projects operating globally, mostly in China and the United States, though there is still short of what's technically possible. In Mexico, the Sabinas coal basin has been undergoing efforts to use captured methane to produce power and reduce emissions, as is the case with Australia's Westcliff mine, where methane is captured for use. On the next slide, we can see that particularly gassy coal regions have a vital need to implement these steps. In places like China, which accounts for nearly half of all global coal production and 2/3 of global coal mine methane emissions, methane mitigation is critical, and it could temporarily be used to reduce fuels needed for existing power plants as they transition to cleaner sources of power. On the next slide, though, we can see that if we really want to see progress, we need transparency in reporting and making investment and policy alignment a priority. There's limited information on how much money is currently going into methane mitigation, but we do know that investment remains far below what's necessary to achieve that 75% reduction target. On the next slide, we can see that one final concern is the emissions continue even after mines close. Abandoned coal mine methane, or AMM, poses a significant concern. Since coal mines can continue to leak methane for decades, we need a proactive efforts to solve this, like flooding the coal mines or properly sealing the vent shafts and entry points after operation. Such efforts could also create local jobs and post-mining reclamation projects. For instance, in a recent study, we found that abandoned coal mine methane in European Union those closed mines could be quietly leaking as much methane that the Nord Stream pipeline leaked during its burst in 2022. So governments, industry, and civil society must work together to provide the financial and regulatory support necessary to scale up the mitigation of methane emissions from active and abandoned coal mines. So here's the good news. We already have examples of companies, governments, and civil society coming together to tackle this problem. No coal operator wants to deal with the dangers of a gassy coal mine. It's a direct threat to the risk of their workers and their operations. Likewise, no government wants to face the scrutiny of being labeled a major methane emitter, as satellite data makes those emissions more visible and harder to hide. So many have already started to sign on to the Global Methane Pledge and align behind the issue. So now is a good time for action. With the right monitoring and reporting systems, investments, and policies, we can solve coal mines' methane problem, one that improves the safety, reduces emissions, can create jobs, and also help put us on a pathway for a sustainable future. So thank you all.
Thank you very much, Ryan, for keeping time and saving us a few minutes. I really appreciate it. We're going to move on to our next speaker. And ladies and gentlemen, I would like to urge you, on your table, there is a red kind of piece of paper. You should write your questions down. After the last speaker, we will go back to your questions. And if we don't get a chance, we'll post them on a sticker outside. There's a board that we have to just record the conversations, your thought process over these last couple of days. And they're going to be color-coded according to the session. And so I would like to invite our next speaker, who is Ariya Khamya, who is from My More Smart City. He is implementing an information development project there. He's going to talk to us about the My More Smart City Development Plan in Thailand. Ariya Khamya, welcome on stage. Thank you very much.
Hello, everyone. My name is Ariya, and I'm part of My More Smart City team, project team. Today, I would like to share some insight from our team perspective as a frontline workers. We relatively new to this type of projects, and today agenda cover getting to know My More in the mine culture, post mining strategy, evaluating social enterprise and our quick win and S-curve projects. Okay, first let me talk about the Electricity Generating Authority of Thailand, or EGAT. It's a state-owned enterprise that operates various types of power plants, dam, and renewable energy source. Today, I would like to focus on Mae Mak Mine and the Mae Mak power plant, which are located in the Lampang district. Marked in the red on the map, as you can see. The distance from the Bangkok, the capital city of Thailand, is approximately 600 kilometers by car or 1 hour flight. Now let's take a closer look at the Mae Mak mine on the peak at the bottom. As you can see, Mae Mak is the largest and only lignite mine in Thailand, located in the Mae Mak sub-district. The mine area spans 63 square kilometers, with an additionally 98 square kilometers designated for mine waste disposal. Operation has been ongoing since 1954 and project to continue until 2040. As we have been mining for 7 years, let me share what we have done so far in terms of reclamation and environmental efforts. Our end-use plan on reclaimed land allocates 93% for reforestation, 4% for recreation area, and 3% for water storage. Currently, we have successfully restored 91% of land, which is equivalent to 51 square kilometers. Over 2.8 million trees from 80 different species have been planted, achieving an offensive survival rate at 88%. Now let's discuss about the post-mining efforts. We are currently in the process of creating the master plan that we expect to complete by the next year. According to this plan, we have approximately 25 years for preparation and development, so we have a lot of work ahead of us. So, as you all know, the Mae Mak mine is scheduled to shut down in 2040, which will have significant impact includes the decrease of the $280 million per year in gross provincial product, or GPP, of Lampang, of course, affecting both of Mae Mak Power Development Fund and Mae Mak Mineral Royalties. Additionally, regular employee and contract worker will be forced to change the field of work or maybe losing their job. Sorry. Okay. Sorry about the font. So that, as you see before, the Mae Mak Smart City project is aimed to uplift the community through the innovative approach. Our concept is of the smart city that not necessarily involve advanced technologies. Instead, we envision the city that is livable and sustainable. Our team consists of about 50 staff members who have experience in community relations. We focus on 3 pillars: energy, economy, and environment. To achieve our target, I will walk you through a model we are developing based on the principle of social enterprise. A social enterprise is generally perceived as a business organization with a social mission, working in the best interest of its communities. We have designed our social enterprise to be united by the city fund. Currently, we have 1 project in the design state and we have 3 in the production state. Let's take a moment to summarize the sum of this project. The first one on the right, on the left-hand side of here, the first project is the community agriculture, where we combine 3 types of farming: organic farming, vertical farming, and household farming. The business model is focused on the production and distribution of the products. Our goal is to connect the local farmers with the consumer and retailer, creating the sustainable and efficient food supply chain. And the second project is the livestock. In this model, we aim to collaborate with the community-based enterprise and the private sector company that possess the necessary technology and expertise. We plan to utilize the abandoned area for this invitation and ultimately share the profit with the city fund. As you can see, this is our first crop that will be cropped about the next month. Yep. Okay, and the third project is the biomass co-firing. We are focusing on the corn, stalk, and leaf. which are often left to decompose or burn, contribution to the pollution like PM2.5. In the northern region of Thailand alone, there is annual biomass potential of 4.2 million tons, which 2.9 million tons consist of the corn stalk and leaf. And another objective of this project is to establish 2 biomass pellet plants in the area of the highest concentration of cornfield. This will help reduce the cost of the pellet production while also cutting down the transportation expense. So on the other hand, over past 3 years of my team working, we have also implemented quick win projects that do not focus solely on the mining or the power plant area. We have spread out our project to the 5 mammoth subdistricts, such as a project at the Green Job Training Initiative in collaboration with GIZ, of course. A project that Energy Management System is a project designed to promote efficiency energy use in public facilities such as hospital or school. Project about the agrivoltaic research project involve 50 megawatt solar PV that support the mining activities. And GSG city data platform that is designed to help the city move toward to net zero emission. So after all of this project that we have done, we have considering all of the above, we have conclude that our current plan does not fulfill the economic impact of the mine shutting down. Even we have factor in EGAT core business investment. Therefore, we are looking ahead to identify new opportunities for growth in this area. We have several assets that position as well as for development, including the transmission line, a reliable water source, a potential to develop RE, a rail ring and container yard that we currently undergoing feasibility study by the State Railway of Thailand. This result makes us well prepared for establishing a green energy industrial park or industrial estate. Here are some extra projects that we believe that have significant potential in Mammoth area, which we are actively promote to the policy initiative and at all at level. So lastly, on the left-hand side of our partnership are vital to success of the Mammoth Smart City project. They reflect the new approach that we are taking to build a collaborative ecosystem and bridge together within the community. So the last one, your insight or your suggestion would be valuable to our team, especially we are newcomer in this field. So thank you so much. ขอบคุณครับ
Thank you, Ariya, for a succinct summary of what is happening in Thailand. For me, the key message there is the focus on SMEs, because if we're really to transition our economies, business as usual can no longer suffice. It means the existing old business models that have locked us into this coal-intensive pathway basically have to give way to new business models, to new thinking, to new products and services and so on. And for me, the focus on SME is absolutely critical at the center of the transition. And for you who are going to go tomorrow, there's going to be a lot of emphasis on SMEs, and you'll see some of the work that South Africa is doing in Mpumalanga, really seeing how do you work communities out of these coal-dependent pathways to creating new business model that can bring about the transition that is required. So really excellent contribution from there. And so our last presentation is a presentation from Adrita Subaya, who is basically making an intervention on the circle of friends of the EGAT project. And he's going to be talking about the Just Coal Transition Platform. So welcome, Adrita Subaya.
The introduction, and a quick thank you to EGAT for having us here today and for this opportunity to just introduce the work that we're doing. I'm sorry if I'm not totally comprehensible. I landed last night, and so excuse me if I don't make full sense. Do we have the presentation? Okay, sorry. Okay, so just a quick introduction. So we are the Southeast Asia Energy Transition Partnership, or ETP. ETP is essentially a pooled fund of both government and philanthropic donors. We have all of the logos listed down there. We're housed in UNOPS, and essentially what we're trying to do is to promote energy transition in the VIP countries, or Vietnam, Indonesia, and Philippines in the Southeast Asian region. So today I just wanted to talk about two of our projects, and these are relevant to our the conference today and the study tour. So the first one is called Transcend, or the Transition to End Coal program. And essentially what we're trying to do is to really support early retirement of coal-fired power plants. So unlike in Chile, which I found the example very exciting, in Southeast Asia, there aren't a lot of early retirements happening. There has been one case in the Philippines, and what we're trying to do is to really replicate that case. We're starting with a pilot, and we're looking at innovative financial engineering to support an investment in renewables. That's something that we've just kicked off. We have one coal-fired power plant that has expressed interest in voluntary retirement, so very exciting. If it's successful, something that we want to go on to do is to really build a sort of revolving fund to support more transitions to happen in the Southeast Asia region. Another initiative of ETP is the Just Coal Transition Platform. This is something that we developed and launched with the World Bank in 2023. Essentially, what we're trying to do is to really support the region on just elements of the transition. So again, working in the three focus countries of Vietnam, Indonesia, and the Philippines. And the focus is on knowledge sharing, capacity building, and enabling access to technical assistance as well as financial resources. So I'll just spend a little bit more time on the JCTP and talk about some of our early activities. So the first thing that we've started is to really look at baseline analytics that are relevant to a lot of the discussions in this space. We're currently doing a study with the World Bank titled Laying the Foundations for a Socially Sustainable Coal Transition. Essentially, what this looks at is what are the basic building blocks that are needed for a transition that is socially sustainable. So how do you start the dialogue with communities, and how do you get them to really buy into the entire process? We're also doing 3 analytical papers in each of our focus countries to really look at what the readiness is for just transitions and where the current gaps lie. And a lot of this will be used by the platform to inform our activities going forward. This is something that we hope to have ready early next year. Another thing that we're doing around specifically coal-fired power plants and early retirement is to look at the social and environmental impacts of early retirement of CFPPs and how some of those can be mitigated. The idea for us is to use the pilot project that I just spoke about to really understand this and develop a framework that can be taken forward in the region. Another focus of the platform is on dialogue, because we understand a just transition, has to be people-centered, and we understand that the dialogue has to happen at every level. So we will have dialogues at the regional level, at the national level, sub-national level, and also at the coal community level. So, for example, something that we're doing in the Philippines next week is to actually have a conversation in Lagunas, which is, outside of the capital city, where you're seeing a lot of renewables come into the city, to really understand what the implications are of renewables coming in terms of the just elements of the transition. We'll also have a regional annual forum, and we're hoping a lot of you will join us. This is going to be in Jakarta on the 5th and 6th of December. It's an opportunity for a lot of initiatives focused around just transition to come together to share, what's happened, what needs to happen in this space. Other than that, something that we have just recently begun, which is really exciting, is we're supporting the JETP process in Indonesia. We've been invited by the JETP Secretariat to support them in developing the Just Transition framework as part of their comprehensive investment and policy plan. It's been a very exciting opportunity. We're looking essentially at investment focus areas that will come out of the JETP process. So looking at, for example, coal-fired power plant closure, but also looking at investments in renewables, so renewables projects, and looking at what the just transition elements of those investments would look like. So that's something that we're supporting the government in developing. We've also initiated a project called Twinning for Decarbonization. So essentially, we look at twinning of subnational actors in the region. We understand that everyone is at a different stage in their journey towards coal phase down, but there's a lot that we can learn from each other. So the idea is really to look at, in the first instance, for example, we're looking at coal communities within Indonesia, so at the subnational level, to see if we can pair them with, other coal regions globally. So we're in the process of identifying which those regions could be. And finally, just to say that we're also looking to support the development of learning tools. So looking at a lot of the resources that are already out there. For instance, there is the resources that have been created by the College of Europe. So how much of that can be really adapted to the Southeast Asian context? And as this is being developed, we'll also have sort of live training sessions that happen on ground in each of our focus countries, obviously in the relevant local languages. So yeah, I just wanted to end by saying a lot of exciting things to come, and I haven't covered everything, so I hope to interact with you during the course of the week. And yeah, feel free to come with questions, discussion, etc. Thank you.
Thank you so much, Subaya, for that excellent summary, and the really around creating platforms, because like I said earlier on, in the transition in all of these together. So platforms like this really do help to bring stakeholders together and so on. So we do have a couple of, we are caught up with time. Yay! So we do have a couple of minutes to ask questions. I don't know if there's any online questions. We start there online, and then we move into the room and see where this goes. So online, yes, go ahead.
Thank you. We have one question from Mamusa Mutolo. Hi, Ryan, who's online. Could this particular type of mining be synonymous to sustainable mining? Ryan, are you with us?
I am, yes. I don't know that you could, reducing methane emissions from mining, I don't know necessarily makes it sustainable. I think that it, so I don't know if it's necessarily synonymous. One of the things you have to remember is that for essentially since mining began, methane's always been considered sort of a waste product, which is that it's a danger to worker and a hazard underground, which is why you get explosions in coal mines. So the object of the operators was just to remove it as fast as possible, which effectively was pumping it into the atmosphere. So that's now the question that's, I think, before us is about how can we reduce those emissions into the atmosphere, not just for the safety of the workers, but also for the climate. So I don't necessarily, there's still obviously environmental impacts of mining as in addition to the emissions, of course. But yeah, that's a great question. Thank you.
Great. Was that the only question from online platform? Is the second one? Last. Okay. So over to you, ladies and gentlemen, on the floor, any questions? I have a long list, but I would like to give you the privilege first. Any question of clarification? If you can introduce your name, can you have a mic here? Introduce your name and ask your question to whoever you're directing it to.
Hi, my name is Aripon from Thailand. So I have questions to Ryan about the methane leakage. I saw from one slide you mentioned that after the coal phase out, the coal mine phase out, still the methane leakage. So I would like to know how long that is going to be done for complete for the leakage, and any technologies right now that can capture the methane, because I think that many countries in the world, in the government, they would like to get the technologies to capture the methane. So that is my first question. And my second question to my colleague, Kun Ariya from Thailand. I would like to know, because EGAT is like the key company in Thailand, but in the last slide, I saw that it's the big deficit in terms of the expenditure and then just really low revenue. So I don't think that the government will allow that kind of thing happen. So I would like to know that any strategy from EGAT to help to capture the revenue stream in order to capture the deficit. So that's my two questions. Thank you so much.
All right. So, can we respond to Ryan? Ryan, can you respond to the two questions, the lady?
Of course. Yeah. So the when a coal mine's abandoned, I mean, I think the general assumption that is that it can leak methane for somewhere around 7 to 8 years with, some certainty. And that depends on just, of course, if there's been any efforts in place, like flooding, for example, or proper sealing in order to make sure to reduce those emissions. But there was a study, like an academic study that was done, a peer-reviewed study in 2020, that actually showed that it was called the Collide study. And it showed that actually some of these mines may be emitting and just leaking for decades. And so that if you were to take a handheld device and hold them over the top, it's a lot longer than 7 or 8 years if nothing is done at all. So that raised sort of a larger concern, I think, among people working on the issue. And then in terms of technologies for capture and was it utilization, I think was your question? Yeah, there is utilization projects currently active in the world. The Global Methane Initiative keeps a list of those. They have a data set on those operating projects. And so there are certainly technologies. I think the biggest obstacles are just logistical ones. It's about sort of combining both active operating mines with building the infrastructure you would need in order to make these utilizations possible, and working with sort of the gas industry and effectively and in that way. So it's certainly possible. There's definitely the technologies to do it. In terms of practically making it happen, that requires a lot of cooperation, I think, between different industries and also between the government itself. So yeah, thank you.
Thanks, Ryan.
Okay. Thank you for the question. I think it's a hard one. I'm not sure I'm the qualified to answer it, but in the term of the graph that you see, I mean that economic impact in the provincial level, and the strategy that we try to do, that we try to do the work that the bottom up. We try to put the idea, the thing that we do to the policy maker. Me sitting here is the one of strategy. Yeah. So that's will be my answer. Thank you.
Any other questions for our panelists? Yes, over there.
Yes, thank you very much. My question is for Ryan. And I would like to know if you know a successful regulatory strategies to implement the utilization of methane in coal mines, but in underground coal mines and also open pit coal mines.
Sorry, Ryan, you didn't have to suffer jet lag, so all the questions are going to you.
That's okay. I missed the very first part of that question. It was about was it in surface and underground utilization efforts? Sorry, I missed the very first part.
Yes, don't worry. My question is about successful regulatory strategies to implement the utilization of methane in both kind of mines.
Yeah, thank you for that question. I actually am not familiar with the regulatory. I haven't assessed sort of the regulatory issues that have been most successful. I can tell you that surface mine utilization is a lot more complicated and it's practically difficult than any underground utilization is. And the big reason for that is that with surface mining, you just have a large open pit in which the methane emissions are just sort of incredibly dispersed and just sort of leaking. So it's not like you have a concentrated source point, which you would with underground operations, like a ventilation shaft. So, I mean, I think the basic thing would, part of what I was speaking about earlier was about the need for that actual monitoring to take place in order for us to take that first step. So I think just general regulatory efforts to kind of improve monitoring systems. We already know that industries are interested in knowing they're monitoring their methane inside underground operations, oftentimes for safety reasons. If we could have that reporting fed back into governments for emission standards, that would be incredibly productive. But thank you for that question. I don't know a lot about the regulatory policies. I appreciate that though.
Thanks, Ryan, for the response. Back to the floor. We still have like 5 minutes to ask questions. Yes, there's one in the center here.
Thank you. I have a question for Nonhlanhla. Is rightly pronounced? Okay, thank you. No, I just was wondering about your research in acid main drainage, but I was wondering the impact on soil. And if there's another initiative, or perhaps the initiative that you mentioned, that aims to analyze or see the ways to recover soil in those areas.
Thank you for that question. There has been some work, like I said, on phytoremediation, which can be used for rehabilitating soil as well as contaminated land. And a good example is the last slide that I shared with the Mafube Colliery project, where they are reclaiming contaminated soil land for agriculture, but after treating it, obviously, and also using treated water for irrigation. So they're irrigating the water using bacteria. So there are some instances where it is possible to remediate contaminated soil and water, but part of our project is part of the output that we're implementing for this GIZ project is exploring as many possibilities and options as possible, so that at the end of the project we provide a concrete way forward on how we are going to rehabilitate soil and water contamination. So we're looking quite broadly, even to the extent of how we can apply wetlands, how we can apply flocculation technology, like some technologies related to precipitating some of the contaminants from the acid mine drainage water. And then for soil, we're looking at how do we remediate the topsoil after it's put back in place, and maybe revegetating or planting some vegetation on top of that, or also looking at open pit lakes as well, and seeing how best to remediate. So we are exploring different options, and at this stage we are consulting with some members of our technical advisory group, so that we also have access to the latest research that is being conducted by the different universities in the country, but not only in the country, because we also have members of the technical advisory group from outside South African universities and other partners. So we are exploring as many options as possible so that we can provide a comprehensive recommendation at the end of the project. Thank you. I hope that answered your question.
Thanks, Nonhlanhla. Any other question for the panelists? If I may just make a quick follow-up, Nonhlanhla, obviously acid mine drainage is very expensive. How is that financed? And a lot of those are legacy related to companies and so on.
That is actually a very serious problem, because I think in my presentation, I did mention the fact that some of the coal mines have been in operation for more than 150 years, from when coal mining started in South Africa, which is precipitated by also the Industrial Revolution here. And so it's difficult, because with some of the owners, they are no longer in the picture or mining those mines. So they in some cases, there's no one that is willing to take responsibility for rehabilitating those areas. So now the burden then lies on the National Department of Water and Sanitation, which already has its own challenges in the sense of aging infrastructure for potable water supply and wastewater treatment, and our wastewater treatment plants and the state that they are currently in. And over and above that, now the department must now grapple with acid mine drainage, so it is very expensive. But I mean, part of the legislation of the country has provided that for someone to get a mining license, they should be able to provide some funds for rehabilitation. The implementation thereof is where then there's a bit of an issue, because in some cases those funds are really, it's an expensive process, and that's part of the problem that we have as a country right now.
Yeah, difficult challenge to navigate. Any other final thought, final question before we wrap this session? Ariya, SMEs are very important, obviously, and one of the biggest challenges, and my friend who is in the room, Rest, who is talking to me, I think he just left out, is around financing SMEs. How do you unlock financing for SMEs to ensure that those projects that we're talking about in sustainable agriculture, livestock, and so on are actually viable? I think bankability is a really important issue here, because I remember you mentioning about vertical farming, how sustainable are those practices and so on.
Okay, thank you for the question. Actually, in Thailand, we have the Power Development Fund. So when we produce the power, we have to spend the money to this fund, and we have the regulator to do what fund have to do, and then our team try to not manipulate, but try to communicate with the community to try to use this fund to do this thing.
Okay. Nice.
So that is, yeah.
Thank you so much.